This conference will now be recorded.
Yeah, today's class is about thread dump analysis again. Don't get confused. You'll not understand the complete thread dump analysis in one single class or two classes. So before you step into this thread dump analysis, right, you need to have some understanding on some basic understanding of core Java concepts. Because the reason is when you want to analyze all the thread dump analysis, right, you need to understand the Java virtual machine overview and the Java and middleware software interactions with respect to different concept components, different areas that are available inside JVM. And also, when you talk about this thread dump analysis, right, you also need to understand about how thread pool works in Java. If you remember from the performance point of view, right? So every time you see some performance issues, so this you most of the times I have seen people increasing the thread pool, which will accommodate where the application server will accommodate more number of threads to execute the tasks. So again, it is not always increasing the thread pool will not help us to fix the performance. I'm sorry. So so you need to understand what is JVM thread dump, and most importantly, you need to understand few basics like what is thread in Java, what is multi-threading, and what is a deadlock. What is that exactly? Every performance engineer will do by taking multiple thread dumps, and what are all the different states? The states, right? The states of a thread are very important to understand what each and what each individual thread is doing at what point of time. What exactly is it executing? What task it is doing at that particular point of time? So at what time it is completing the execution, or how it is picking up a new task from the queue, and how it is executing it. So you need to understand all the different thread states like new, running, blocked, waiting, and timed waiting, and the last state of a thread is terminated. There is also a concept in thread dump analysis which is called the thread life cycle of a thread. So like how a thread is created, when it goes to running state, when it goes to blocked state, when it is waiting, and when is timed waiting, and how it is terminated. So before I start, whatever the thread problems that I'm showing, I'm sharing it on the screen. These are all different issues that you see. So I'll tell you one single answer for thread dump analysis. If the question is when do you take a thread dump, okay, or what is the reason for you to take a thread dump? So the only answer is if you see any kind of slowness, any kind of degradation, or any kind of stopping point, right? If the app server is going down, or if the web server is going down, or if database server is going down, or if you are getting a feedback from the real-time users saying that we are not able to access the application at after 12 o'clock in the night, or we are getting some still getting the response, we are getting some it is taking 8 to 9 seconds of time to load the page, or you are seeing some HTTP errors like internal server error, or page not found, server not found, or if you think that all of a sudden you are accessing the application and it is saying that access denied. And anytime you see when you are testing an application with high load or minimal load, or if you're doing some gradual increase of load testing, concurrency testing, simultaneous testing, you always tend to keep an eye on the CPU utilizations, like how the CPU is utilized, or how the memory is utilized, how the disk is utilized. And you also monitor the network metrics. You keep an eye on all of the different metrics that are available across the infrastructure when you do this load test. And anytime you see the CPU spinning or some abnormal numbers with respect to memory or disk, you take a thread dump. And anytime if you have a high GC pause time, or if you think that GC is not happening, the memory is not freed up, the slow performance, and obviously hung threads. When you take the thread dump analysis, only when you take this thread dump for multiple times during the load test, you will know the state of each thread, what each thread is doing, right? And again, application goes down, application not available, server struck, app crashing, server, app server hangs. These are all nothing but application is not responding. It means that the application is not behaving as expected, right? So there are few scenarios where you will see lot of timeout errors. It means that if you take, for example, if you take I don't know how many of you are aware of IRCTC, which is an Indian Railways online booking ticketing system. So most of the times people try to book a ticket at 10 o'clock and 11 o'clock for Tatkal, which is an immediate ticket facilitation. So what they do is at that point of time, uh, the application will have a peak usage. It will have a high user base, and when you try to select your seat, date of travel, type of class, and when you give your card details, and when you click on make payment, you see a message saying that uh, please do not click on back or refresh button, your payment is being processed. But what happens is, even till date, okay, even today, this ticketing system site has been created some 12 years or 15 years ago. It is started from 2006, 2005. Okay, so from the last, this is the second generation which came up with the IRCT second generation, which is there in live now, which came up with so many performance improvements. Even today, when you click on make payment, you see a message, please do not click on back or refresh button, your payment is being processed. And after some time, you get a message saying that we cannot book your ticket, but the amount from your respective bank account will be deducted, and you see a message saying that your amount will be credited into your respective account within the next 7 working days, which is a very big performance issue. Okay, and that is a very frequently used application with high number of users with high concurrency, which is used from different locations across India, using different machine configurations, different bandwidth, different browsers, different operating systems. But irrespective of anything that you use, the application will not respond. Even if you're trying to book a ticket from 200 Mbps or 1 Gbps internet speed with i7 machine or a MacBook using Safari browser, you cannot book a ticket at some point of time. If you're trying to book a ticket for continuously 3 days, any among these 3 days, one single day you will see this performance issue saying that your amount will be deducted and you will not be able to book the ticket, even if you have an availability, even if you have the seat availability of the train that you have selected. So this is a very big performance issue, and the reason why it is not that they are not able to meet the SLAs, or they are not able to meet the performance numbers. It is like it is a government project, and the budget of that on that application with respect to infrastructure and capacity planning is minimal. Government will not spend too much of money like Amazon, right? That is why the reason it will not scale up, or it will not behave as expected. So every time I see this issue, I go back and I see thread problem. I take my thread dump analysis and heap dump analysis, because my application is giving so many issues, so many performance issues. So my application is crashing. I'm not able to book the ticket. I see a high CPU utilization. I see application slowness. I see some serious performance issues. or sometimes it is saying that it is the site is not the site is unavailable or server stuck. These all things will happen in an application like IRCTC. All these thread problems that are being showed here right on screen are these are experienced by a simple application like IRCTC. Okay, so before you take any of the thread dump, right, you have to understand all the environment and the different tools that can help you to take different thread dumps. Okay, so thread dumps, you have n number of ways to take a thread dump. Okay, and you have different tools that are available in the thread dump. So I'll show you everything on in real time. I'll show you how to take a thread dump, how to analyze that, how to read the thread dump. Don't worry about that. So I'll clearly tell you that is why the reason I have shared you this JProfiler. Try to install that on your local host, and they have in that version of JProfiler you have some demo servers which are already configured. And if you have, you can also try with any one of your JVM. You can install it on any on your other machines. If you have any other laptop, you can install it. You can directly connect to that JVM, and you can, with the process ID, you can monitor all the heap, all the threads, and you can take heap and thread dumps accordingly. I'll show you that very clearly. Okay, don't worry about that. So before I go to thread dump, so can you tell me what is thread dump? Anyone?
It's like getting all the threads along with their state and what they were doing on that instant at that
R-
instant.
Right. So dumping is a very well known term for every performance engineer, right? Every performance testing project will have a dumping. Either it can be a heap dump or it can be a thread dump, or both of these important activities for every performance engineer, right from the uh, first day, even if he's having 1 year or 15 years experience. Both the thread dump and heap dump are very, very useful to carry out the root cause analysis. And remember, most of the service-based companies, especially the banking projects, BFSI domains like JPMC, Wells Fargo, Bank of America, or Charles Schwab, different banks, right? They'll not allow performance engineers to touch the production environments or the QA environments. The scope of performance engineer can be, there are chances of uh, there are chances of having the scope limited. They will not have the complete access or privilege to directly jump onto the app server or the DB server, or they cannot directly take the heap or thread dump. Thread dump analysis, for sure, most of the companies they don't give chance to performance engineers. Again, uh, as much as possible, it is you who has to convince your customer, or it is you again who has to make the customer and different teams to understand how thread dump analysis will help to investigate the root cause. Okay, and if you want to give any suggestions or recommendations with respect to the performance issues, you have to tell your teams that thread dump is really important, really necessary to take it, to analyze it, to investigate, and there from that point you will take the necessary action items on what to do next. Okay, now let's try to understand what is thread dump and how it can be analyzed. Like heap dump, we already discussed everything about heap dump in our previous sessions. Like heap dumps, thread dump is a snapshot of the status of all the threads at a particular time, and there is no limitation. You can take a thread dump at for n number of times, but taking a thread dump for a very shorter duration will help you to quickly identify the root cause. Okay, so these thread dumps, what it will do is they'll collect the complete information of all the threads to diagnose CPU spikes, deadlocks, poor response times, memory leaks, memory problems, and slow response times, unresponsive applications, and other system problems. And I have shown you so many problems, right? any problem with respect to performance can be investigated by thread dump. So for example, if some threads are struck, they create a deadlock. I'll tell you what is deadlock. Okay, so and if you see all these issues, so basically you go back and check whether all the threads are running or not. That is second point. Okay, so the third point is, if all threads are running, if you look at all the threads, which threads are waiting for the blocked resources. If some resources are blocking, uh, if some threads are blocking some resources, the other threads which are trying to access that particular resource, they'll remain in blocked state, and they will stop executing that particular task which they are supposed to do. So such things will happen, and you will check all these things like which threads are struck, how many deadlocks you have, if all the threads are running or not, and how many blocked resources you have, how many waiting threads you have. All the questions, all the issues can be identified, or can be analyzed only by taking a thread dump. Okay, so before we talk about more on thread dump, I would like to talk about some of the basic terms which are really helpful to understand the concepts of thread dump. Okay, now can you tell me what is thread? Stay focused. This is very important part for any performance engineer. So stay focused, and we'll make this session interactive. The reason is because every performance engineer has to take a thread dump, no doubt about it. 40% of the issues will be directly identified from the thread dump. Okay, so can anyone tell me what is thread now?
A thread is like a small piece of code in a big program or big application.
Yes. So basically, a thread will have a series of statements that can be processed, or that will be executed in parallel in the same program to achieve something called concurrency. Okay. That is why the reason Java also came up with multi-threading. Multi-threading means it will have too many threads will be performing same tasks or different tasks at the same point of time or at a different point of time, right? So all these Java threads will be managed by JVM, okay, which are mapped to the operating system thread, also called as native thread. Native thread is nothing but the threads inside the JVM which are mapped to the operating system, right? So these operatings, the threads which are, every thread will be mapped to operating system. So operating system thread. So, and this thread is called native thread. And each thread will have a unique identifier, name, thread ID, category, and some of the basic features of thread are like, most of the times, if you go back and if you check any of your performance testing application, there is one option, and there is a commonly asked question in all the interviews, like what is the difference between running a view user as a thread and running view user as a process? You remember? why
Yes.
why do I need to run my view user as a thread, not as a
Mm.
process?
When we run as a thread, it will consume lower resources, less resources like
Right.
CPU, memory, but the process requires more resources.
Right. I don't know how many people I mean, how many of you remember something called Orkut, which came along with Gmail before Facebook. Okay. So the earlier versions of Internet Explorer, if you open your Gmail IE6, okay, it will open in one window. Okay, if you open Gmail, it will open in one window. Now, earlier there is an option called Orkut in Gmail. When you click on Orkut, it will open another IE window. It means that it is opening the second process. The first process in the IE opened, I mean, which is opened is Gmail. When I clicked on Drive in the Gmail, it will open in another browser. The same, it is not the same instance, but if you take it the latest browsers, right, there is a plus symbol. This is a thread. Another new tab is a thread. This is another thread. So what happens is this one browser that I'm using is basically a process. Okay, whatever the different tabs that I'm using, they are multiple threads that we have in a process. That means a browser. Basically, the reason why I use run user as a thread, not as a process, is because if you're running one user as a process, it will take 2 MB of memory. Okay, so for 50 users, it will occupy 100 MB of space. But when I run user as a thread, okay, one user will take 2 MB. How much memory will take for 50 users?
100.
It would be same.
It is same. It for 1 to 50 users, when you run user as a thread, it will take only 2 MB. From 51 user to 100 users, again it will take 2 MB, which will be 4 MB for 100 users. But it is not the case with process. Okay, if you want to check the high memory utilization, if you want to give a try with a different type of stressing the application, this is one way you can stress by running user as a process. Okay, so basically a thread is a very lightweight process and very faster than a process. Okay, the reason is because threads will share the same address space. That is why the reason they can share the same they can share both the data and the code. And context switching between threads is usually less expensive than processes. I'll talk about what is context switching in the next session. Context switching is also another question from the engineering standpoint. People will ask you what is context uh, switching. How can you make use of that metric? What exactly uh, it will tell you or it will define? So I'll talk about that later point of time. So the most important part is it is a lightweight, faster than a process. They share the same address space so that the data and the code can be shared among the different threads that are available. And what these threads will do is they allow different tasks to be performed concurrently and simultaneously. Okay, so that is all about threads, the basics of a thread. And if I talk about multi-threading, so what is multi-threading now?
Multi-threading is like multiple threads will be executed at the same time. Uh, like when we say our V users are best example for multi-threading. We run
Right.
50 virtual users, so that is all of them are threads.
The one of the main feature that Java came into evolution is because the Java came into limelight only because of the concurrency feature that it has and the multi-threading concept. Okay, basically Java is a multi-threaded application. Whatever the application that you can that you are trying to develop, right? It's suppose multi-threading concept, which will allow multiple thread execution at a particular time. Okay, and basically if you take any web server, right, it will use hundreds of threads to process a large number of concurrent users, which will achieve multi-threading. Multi-threading is like any application concurrency has to be there, right? If you take any of the Amazon site, there is too much of concurrency. There is too much of simultaneous hitting on the application. It means that if you have an Amazon big sale or a Black Friday, it means that 5% of the users out of maximum handling capacity of the application are doing the same activity at the same point of time, right? For example, even if you have TCS, I don't know how many of you are working with TCS. Okay, TCS have some 4 lakh IT people. Okay, so every employee, if they want to check their pay slip, uh, most of the people they will check the pay slip from uh, date 1 to 3 or 5, from 1st of every month to 5th of every month. So all the 4 lakh people will go back and check the pay slip for the month of March because they'll have some tax deduction. To understand that, Out of 4 lakh users, at least 5% or 2% of the users will have concurrency. That means that to check the payslip, they have to go to the Ultimatics portal. They have to go to some different application. They have to log in there, and they have to select the month, and they have to click on view or download to check the payslip. So out of 4 lakh employees, 2% of the employees, which is 8,000 or 5,000 of the employees, will do the same login at the same point of time without with no gap. There will not, there even you will not see the difference of milliseconds. It means that 3 to 4,000 users will be hitting the application at the same point of time without any time gap in milliseconds. They open the browser, at least clicking on login. All the 500 users has to deposit the cash into the account at the same point of time. We'll use Rendiverse point, right, in the load runner scripting. So in the same way, when you have too much of concurrency, if you want to see the concurrency of the application, this multi-threading is required. Okay, but the only problem with multi-threading occurs when two or more threads utilize the same resources, and if they're not getting released, and that leads to a deadlock situation, and you will start seeing the performance issues. Okay, now let us talk what is deadlock.
Deadlock is like one thread is waiting for the resource to be released by the other thread, but that thread is not releasing that resource. So that would
Right.
be.
Yeah, if you take a scenario, thread A is holding a resource X, okay, and thread A needs resource Y, which is blocked by thread B. Simple. Got it? You have a thread A that is holding a resource X, and it has to access the resource Y, which is blocked by thread B. That means that thread B is already holding resource Y is already holding thread B. So both the resources are not, they are holding two different, both the threads are holding two different resources, and each thread is trying to access the other resource which is holded by another thread, and that is not being released. So in such cases, you will have a deadlock, and there will be no progress within a program. Nothing will get executed. So how to avoid deadlocks? We cannot directly go and directly delete a deadlock. The only way to eliminate a deadlock is when you report the same issue back to the developer. He has to write a code in a way that where a deadlock will never happen. So that is what he has to do from his side. If you take any developer from the development team, he has to write a code in a way that deadlocks will not happen in the application. There is no other alternate remedy to eliminate the deadlock. You cannot use any tool to remove the deadlock. You cannot directly go back and make some changes in the code. It is not a performance test engineer's job. Okay, so deadlock is like you have a situation where two or more threads are waiting for the other threads to complete their tasks in order to complete their own tasks. Okay, to identify this root cause of any deadlock, you need a thread dump. Okay, you understand? So again, I want to reiterate the same thing. What is thread dump? Uh, it is a snapshot of all the threads to understand what each thread is doing at what point of time. And this thread dump, right, it will help you to analyze and it will help you to find out what every thread in the JVM is doing at what point of time. To understand how many threads are stuck, how many deadlocks we have, how many threads are running, how many threads are waiting, how many threads are timed waiting, how many threads are waiting for the blocked resources. All these questions will be answered only by analyzing the thread dump. Got it? So to analyze this thread dump, it is very necessary to understand the different states of a thread, and you have let me open that. You will have multiple images. Don't worry about that. So you can basically access any image, but let us go with a simple diagram. This is the diagram. This will tell you what exactly it is. Okay. So basically, what is new? If you look at the new thread, right? What is new state of a thread?
It was just created at that time, like
Okay. So this is the initial state of the thread. Thread is created and it is in the new state. The thread has not yet started to run. It is just ready. That's all. It is just born, or it is just created, and it was put into new. Okay. It is not doing anything. It is not running. And what is the next state?
Runnable state.
Okay. So what is it? What does it mean?
So it will start occupying the CPU and the other resources.
Yes. So now the thread from a new state, a thread that is ready for run, is moved from new to runnable state. Okay. In this state, a thread might be actually running, or it can be ready to run state. It means that it is not running. Okay. It is in ready to run state, or it can be actually running. Both the states come into runnable state. But again, there is something called thread scheduler. I'll show you what is thread scheduler. Okay. So thread scheduler is an inbuilt feature of JVM again. So the responsibility of a thread scheduler is to give the thread, and it has to give some time to run. It will make sure, it will actually take care of the thread, what it has to execute, and at what time it has to run. It is the responsibility of the thread scheduler. So in this runnable state, I told you, right, it can be actually running, or there is an intermediate state called ready to run. Ready to run state of a thread also fall under runnable state. So this ready to run state comes because every thread runs for a short while, and it pauses for some time, and it actually releases some CPU to another thread. So in such situations, what will happen is the remaining threads that are in queue will get a chance to run. It means that, so the ready to run threads, it depends on the thread scheduler, which thread has to run and at what time it has to run. So most of the threads from this intermediate state called ready to run state, right? What happens is few threads will run for a very short while, and it will pause for some time, and it will release the CPU that has been consumed, and it will give chance for the remaining threads to run. That again happens from the thread scheduler. Okay. So threads that are ready to run and waiting for the CPU are currently running threads which lies in runnable state. So a simple line, you can say that the threads which are actually running, or which fall under this intermediate state ready to run state, they come under runnable state. Okay. Now can you tell me what is blocked? If you look at the diagram, what is blocked?
it's related to that locking, like one resource is locked by other thread, and this is waiting for that resource to be released. But
Released.
Right. So a thread is in the blockout state when it tries to access a protected section of a code. Why I called a protected section of a code is because that particular protected section of a code is already locked by some other thread. You got it? So a thread will directly go into the blocked state when it tries to access the protected section of your code, because that protected section of the code is already locked by some other thread. Can you please place your call on your mute because I'm hearing a lot of disturbance. Yeah, thank you. So when this protected section is unlocked, right, again the thread scheduler picks this blocked thread and it will move to runnable state. Okay, when you will see the protected section unlocked, the other thread which has been locked, right, that has to release that particular resource which is actually which is trying to access by another thread. So when this particular protected section is unlocked, the thread scheduler picks this blocked thread and it will move to the runnable state. So in thread dump analysis, the most important states that has to be investigated is blocked state. Okay, blocked state will give you so many deadlocks. That is why the reason when you take the thread dump, the first metric that you see is the first state that you look at is the blocked state. You need to analyze which threads are in blocked state and you need to understand for what reason they are blocked. Okay, so if a thread is blocked, right, it cannot execute, it cannot continue its execution and it cannot be moved to runnable state. Any thread in this blocked state will not consume any CPU. The reason why you have to remember this point is because, sir, I have seen a high CPU utilization. I am now checking for the blocked threads, right? Any thread which is there in the blocked state will not consume any CPU. If that is not consuming CPU, you should not see the high CPU utilization, right? So if by any chance, if you notice that some of the blocked threads are consuming CPU, that is a very big bottleneck. For example, if you take a real life example, right? If you are going for a job interview, okay, you woke up early in the morning and you got ready and you just came out and you're searching for your bike. So then you realized that your friend has already taken your bike. Okay, so here what is blocked? You'll not be able to, you are blocked, you are in blocked state. Got it? So explaining it in technical terms, you are the thread 1 and your friend is the thread 2 and the lock is the bike. That is why the reason thread 1 is blocked on the lock, that is nothing but bike. Got it? Because the thread 2, your friend has already taken your bike, so he acquired the lock. That is why the thread 1, it means you are blocked. You got it right? So blocked state is nothing but if you have thread 1 and thread 2, you are trying to do something as a thread 1 and thread 2 is already doing it and he acquired a lock on that, and for that reason, for thread 2 acquiring that particular lock, the thread 1 is not able to continue further. The thread 1 is blocked. So this is nothing but the remaining thread is acquiring a lock and the current thread is not able to execute or not able to move forward with the current executing task. So obviously the current thread will go to blocked state. Okay, so what is a waiting state here?
Thread is waiting for other thread to complete its task.
Okay,
There's something called notify, I think, that notify method when it is.
no, we'll forget about that. This is a
Okay.
development concept, so we will understand in another direction. Yeah, when a thread is in waiting state, right, it means that the thread is waiting for the response from another thread, okay, to fulfill some conditions. If you look at the thread dump, right, you see waiting on condition. Did you ever see in the dump, if you look at any of the thread state, right, uh, you will see a thread with a thread id called waiting and it says that waiting on condition. Did you ever see that? Okay, let me show you when I show it to you with the JProfiler. Okay, similar to blocked state, waiting state also is an important state. Okay, that has to be analyzed during thread dump analysis. We need to analyze which threads were in the waiting state and what was the cause. That is the most important point. The first priority is blocked threads, and the second priority is waiting threads. If your currently running thread is moved to blocked waiting state, it means that another thread in the running state is scheduled by the thread scheduler to run. Okay, again, it is always the responsibility of a thread scheduler to determine which thread has to run at what point of time. So you don't have a complete controller or thread scheduler. Thread scheduler will define what each thread has to do what. You don't worry about how threads will work. Okay, thread scheduler will automatically take care. And there is a thread pool executor which came up with since Java 5. I'll also tell you that. Okay, so the amount of time, the amount, for example, you have some work. I mean, if you come for an interview, right? You are done with an interview, and if I ask you to wait for some time, HR will get back to you. Okay, you are done with your interview. Your assumption was like I did the interview well and I got selected, and you did not get any feedback from the interview team, interview panel, or the respective HR from the company. So you can wait. The HR will get back to you. That is nothing but waiting. You don't know the time. You will keep waiting until and unless the HR gets back to you. I mean, you have to wait. Like he can call you in a day, or he can call you in a month, or he can call you in 2 weeks. That is nothing but waiting state. You don't know the timing, but you will keep on waiting. You will be stuck with waiting. Okay.
Yeah,
So
it's a classic example.
yep. So if you there is another timed waiting, right? If you go with timed waiting, what is timed waiting?
It will wait for a particular time, which is given.
There are some methods actually. Okay, there are some when it I mean a thread lies in this timed waiting state. Actually, when it calls different methods that we have, like there are some different methods, some important methods like wait, okay, or sleep, or join, or park. I'll tell you tomorrow what are that. So without a timeout parameter, they can park, or they can sleep for some time, or they can wait for some time, or they can join something. Okay, so a thread basically lies in this timed waiting state until the timeout is completed or until a notification is received. If you There will be some kind of notifications from a thread scheduler. If you get such notification, right, until and unless you get some notification from that, a thread will wait for some time. That is nothing but timed waiting. Okay, it will not have any timeout parameter. It has to wait for some time. It has to wait for longer time. It is not like that. There is something called uh, there are 4 different methods for this timed waiting. We'll talk more about that. Mostly I'll explain you when I show it to you in JProfiler. The park, the sleep, join, and wait. So if you see most of the threads, you will see a message. If you are taking a thread dump file, right, you will see a message saying that waiting on a condition. It can be a waiting, or it can be a timed waiting. Timed waiting is nothing but you will have some conditional wait. I don't know how you will set that conditional wait, but I should have one example. I'll tell you that. Okay. So timed waiting is nothing but how to explain you this one. Like for example, you okay. For example, you and your friend are working in the same company. Okay, so he requested you for a for a carpooling. So you go home and you wait outside for your friend to come. Okay, for to pick him up, you will wait. You call him and he says that it will take 10 minutes. You can wait. So you have a call in the next 20 minutes. So you will wait for 10 minutes. He's still not coming. You wait. You waited for 5 minutes. He's still not coming, and you waited for another 5 minutes. Still not coming. You have only 10 minutes left for your call. So you waited for some time, and you moved from that place. That is nothing but timed waiting. Here, your if you are a thread 1 and if your friend is thread 2, okay, you will wait up to 10 minutes to release a lock from thread 2. If your friend is not releasing the lock, it means that if he's not coming out in 10 minutes, you start driving the car again. It means that the thread 2 will do its task. It is nothing but timed waiting. There will be some condition set for a specific amount of time, and if that based on that condition, it will wait for that particular amount of time. If that condition is satisfied, not satisfied, doesn't matter. After some time, whatever the time that you have defined, if you are not getting that response from the remaining thread, or if it is not releasing that particular lock, you will start moving and you will continue to do your work. You understood? So the last state is terminated. Terminated is nothing but the thread will terminate when it completes its tasks, or when it completes its job. Okay, when has been completely executed, it will get terminated by releasing the CPU and memory. Okay, when basically a thread will terminate when the code of the thread has entirely executed by a program, or when it completes the activity which is supposed to which it has to perform. When both the things are satisfied, right, the thread will automatically terminate it. And there are another basics of thread types, right? You have two types of threads. Do you know what are they?
It's daemon threads.
Hmm. And the second one is what?
Second one, I don't know.
It's a non-daemon thread.
Non-daemon threads.
Okay, we'll clarify the questions in the last. Okay, I have seen the chat just now. I'm sorry. So, what is your question? Okay, yeah. Daemon threads and
No, I
saying
just
something?
guessed non-daemon threads.
Okay. So, what is a daemon thread now?
Example is the garbage collection. We discussed that like JVM runs that in the background daemon thread. Garbage collection is run by a daemon thread.
Daemon threads are background threads which are very low priority threads. Okay. Don't worry about the daemon threads. I mean, if you compare it with non-daemon threads and daemon threads, you have to look at user. Non-daemon threads are also called user threads. The first thing that you have to look at is non-daemon threads, which are also called user threads. And when I talk about daemon threads are basically which runs in the background, and they are very low priority threads. Okay, and the life of daemon threads depends upon the user threads. Okay, and all the daemon threads are created by the JVM. Got it? When you come to the non-daemon threads, it is also called user threads, which are called high priority threads. And this mainly user threads, right? They are specifically designed to do some specific task. Okay, and user threads are created, the non-daemon threads are created by the application, not by the JVM. The garbage collection which runs in the background, which is called daemon thread, all the daemon threads are created by JVM, and all the non-daemon threads are created by the application. Got it? So the another main important difference between daemon thread and non-daemon thread is, in daemon threads, the JVM will not wait for the JVM will not wait for daemon threads to finish their work. Okay, it will not wait. The JVM will directly exit as soon as all the user threads finish their work. But when you come to non-daemon threads, right, JVM will wait for user threads to finish their work. It will never exit until all the user threads finish their work. That is the only difference. But when you take about when you talk about the thread dump analysis part, user threads is the most important part. Okay, you need to look at all the user threads, because user threads are specifically designed to perform some specific tasks. And again, this can happen concurrently or it can happen simultaneously. Okay, and I told you about different threads, right? I mean, not threads, different ways of thread dump generation last time in the previous class. uh, it In the previous class, I have already explained about thread dump generation. It can be done through various methods, especially on Windows Server and uh, Unix, Linux flavors. So the first step is always, you remember, if you want to take a thread dump, the first step is always to know the Java process ID running on the server. Okay, only if you know the Java process ID, you can simply you can simply take a thread dump by using a JStack command. You know the JStack, right? You have everything in Java in the JDK bin folder. Uh, so you have lot of different tools that are available, like JStack. I don't know where is the JStack. JHat is JHat. With JHat you can take JMC Java Mission Control. With Java Mission Control you can take, and there are multiple options that, see, JStack, JStat, JStatD, JVisual VM, JConsole. You can use all of them to take a thread dump. Okay, by just knowing the process ID, it will be easy for you to take any of uh, the thread dump. But you need a process ID. Okay, so on Windows Server, you can download this Java dump.exe. You can start the JVM with some arguments. I'll show you where you need to set that arguments, and they must be in the right order when you set them. Okay, there is something like unlock diagnostics via VM options, or you need to give the log file output, and you have to go to the task manager, and you need to know the process ID of the Java process in details tab, and you have to run that command with the process ID, and you can see the thread dump. So instead of breaking your head by doing all these activities, you can simply use Java Visual VM or JConsole, or see, for example, if you JVisual VM, if you can uh, add just add D connection, I can use my remote host. Okay, so let me see if I can add that. This is my machine. Okay, this is my Windows machine where my WebLogic is
Okay,
installed in the application. Yes, please.
I guess App Dynamics to have a function that takes a thread dump, right?
Right. Okay, I don't know the port name. So, if or I mean, see, uh, earlier, right? We used to use all these different tools to take all the Java, heapdums, threadums, and all. Now, with all the APM solutions that we have in the market, right? You have everything actually. I mean, it will capture anything for you. You can directly go back and you can take heap snapshots at any point of time. Oh my God. Okay, if you go back here, it is not this one. See, if I go to new session, right, you can go to new server integration. You can directly add any of the application server that you have. See, it can be Glassfish, or it can be WebSphere any version, or it can be JBoss, or it can be WebLogic server. I have a 12C, not on this computer, on a remote computer I have. So I can add that. I'm sorry. So this is how you give the address, and I don't have some directories and all, but this is how I'll show you tomorrow when I completely show it to you how to analyze thread dump and head dump, sorry, heap dump. So simply clicking on thread dump, right? If you click like this, it will take a snap of thread dump, because I don't have any activity running. Taking a thread dump and heap dump is not a rocket science. You can go and see all the threads. See, the status is waiting here. You can see, go to the threads. You can go to thread dumps. If you click on if you double tap this one, it has to show you all the thread thing. So see, if you go to JDBC server, it's good to go actually. Open a new window. What happened to this one? I need to reinstall or something. I'm sorry. I think the trial version has been expired. Let me see. So you can do this integration. That is how you do. If you have a JProfiler, right, you can directly install it on where the app server is installed. But you can also install it on your local host where you are trying to execute your load test. You can directly configure to the app server, and you can profile how. I mean, irrespective of how many number of JVMs or application servers you have, you can directly add that. You can directly connect to that one. You can also do manual configuration by giving all the you can also add the different JVMs, the number of JVMs to this JProfiler, and you can get connected. Okay. uh, It is directly you can launch the JProfiler whenever the application, sorry, whenever the JVM is started, whenever it is doing some activities, it will directly launch the JProfiler automatically, and it will start looking at all the different metrics from the memory, database settings, everything. So you can directly go there and see for the configuration that you can set depending upon you have to get, before you do this integration, right, you have to get all the required details from the VAS admin, who is your the one who works on your application, this thing, right? He has to take care of all the different activities. Allow me a minute. So I have a JProfiler installed on another machine. If it is working there, I'll show you that. Let me connect. I'll give one last try. Okay, no. So hang on. I'm, st- I'm sh- Are you able to hear me now? Because I connected from two different machines.
Yeah,
Yes, let me show it to you. Okay. Can I make any one of you as an organizer, because I have to leave from one of the machine to show you that.
yeah, you can make me, Mahesh.
Mahesh, you got the access, right? You're now the organizer. Hello?
Okay.
You're the organizer now, right?
Yeah,
Let me disconnect from this machine. Mahesh,
okay.
so, can you make me an organizer now?
Mm, what is your name here?
Isha.
Isha 1.
Okay.
So the license on that machine has been expired. So if I go to demo server, right? So now it is starting some demo server, and you can simulate some traffic on this. I don't know how many have installed. If you install, right, you can directly access some demo server. Okay, now I'm giving high load, simulating JMS message handling, simulating servlet requests 280. Okay, now if I give this simulation, you will see all the different metrics here. So you can also see some of them are using a word called last time, if you remember in the class, sawtooth pattern. This is how the GC will happen. The memory will utilize and GC will run, then it will come down, then it will again utilize, then it will come down. This is nothing but sawtooth pattern. If you see the sawtooth pattern in the memory utilization, it means that you have a efficient garbage collection. Okay, so if you go, you can directly see the memory statistics like this. Okay, the committed size, free size, everything you can see like this. And if you want, if I click run GC here, it is saying that garbage collection has been triggered, right? You can directly run GC like that to see whether the memory is going down or not. You can look at, you can also record all the allocations of all the objects here. Total number of objects, you can see all of the history here. The recorded throughput you can see. And most importantly, you have to see the garbage collection activity. You have to look at all the different classes and you have to look at the threads. If you look at the threads, how many threads we have? Total number of threads are 23 threads we have. For now, you don't have any blocked threads. That means that you'll not have any performance impact. If you see the waiting threads, you have to see whether you have the timed waiting threads, or if you have the parking or waiting or different threads, you have to go here and check. Okay, this is the CPU load. If you look at the CPU load, because of the high load that I'm simulating, if you look at this, if you look at this metric, sometimes it went up to 99, 71%. There is a high CPU usage, right? Then you can go and see the live memory of what different classes or packages it is taking high amount of memory, and you can you can take a snapshot of this one care which are taking 1747220 KB, and you can send a snapshot of this allocation tree to high memory utilizations of all the objects to the uh, development team. If we click on perform full GC on the soft references, you can select weak references. I told you the type of references, right? GC on weak finalizer. These are all the different type of references types that we discussed in previous sessions. So you need not select all of them, but you can go and start playing with the different options that you have in the tool. It is now taking the snapshot of the heap dump, right? Now you will directly get a heap. This is the heap dump. Okay, it will clearly give you all the different allocations, classes, biggest objects. You can see like this. how much time that has been sent. You can go and check the graph of this one. You can also add objects to see how many references you have. If you go back and investigate, right, there is a separate tutorial for JProfiler. If I get some time, I'll teach you everything in JProfiler, how you have to investigate the heap dump, how you have to investigate the thread dump. Okay, this is a very simple method to take a heap dump. Okay, don't break your heads. There are many ways and different types. You can different tools that are available to take different heap dumps and thread dumps. Okay, this is a very simple way, and you can record your CPU data for all the different thread groups that you have. You can select the threads which are running. If, for example, if I want to know the CPU utilization for all my waiting threads, I go here and I see my CPU utilization. Okay, this is basically taking all the thread groups now. CPU is okay. So if you want to look at, if you want to filter the type of thread state, and if you want to see the CPU utilization, this way you can go and see. Okay, and most important part is threads. You can go back, see by all the threads only which are alive or which are dead. By looking at all the dead threads, it means that you will try to check if these threads are occupying some memory or eating some CPU, and you cross investigate to see if some threads are not being deleted from the CPU or something, and accordingly you take the necessary actions. Okay, and if you take the thread monitor, it will directly tell you the start time and which thread is running. It will have a thread. If you go to a particular thread, it will give you the pool number. The thread pool number is pool 1, and it will tell you which runtime, which group it is running, and at what time it is running, and the status of it. You can check the status like this: running, waiting, and all these things. And again, coming to the thread dump, if you take this thread dump, right, and thread dump is created. Again, if you tap like this, it will create another thread dump. Okay, so this is a waiting thread. If you look at this color, right, it means that waiting. So you have to go back and see why this thread is waiting. Okay, there is a lot more to talk about thread dump. Okay, you can also record the database activity. You can go here and you can record the different database activities of all the JDBC connections, and you can see what is happening with connection leaks and hotspots. And you can also check the, see, if you go to hotspot, it is giving all the queries, right, what is taking high amount of time. So you can provide, you can do all these activities only by using JProfiler. If you are learning JProfiler end to end, all the different metrics, JProfiler is very big actually. If you compare it with JMC, JConsole, JVisual VM, JProfiler is very, very big. If you know how to, if you install this, if you start playing with all the options that are available, you will get a very good understanding on how you can analyze the thread dump analysis, heap dump analysis, what is heap worker, how you can configure JProfiler with multiple JVMs that sits on different flavors of Windows, Linux. You can look at all these things. So the first and foremost prerequisite is you have to install this one. Try to install this one, extract that zip folder. How many of you have installed?
I have installed. Okay.
If you don't start doing some hands-on exercising, it will be very hard for you to understand. Theoretical classes will not help you at all, I promise. Even if you pay lots of money to different classes, it will not help you. I would strongly recommend you to install it. There are some demo servers. I'll also help you with the WebLogic installation, how to configure that WebLogic to your JProfiler. If you configure that, it is like a real-time practice. All right. So, and Mahesh has asked me one question. So the size of maximum threads, okay, it depends upon the environment or the type of machines that you're using, the type of middleware that you're using in your architecture, and the type of Java JVM infrastructure. Basically, uh, it is like 32-bit. We have. It also depends upon the stack size, because stack size will hold the thread IDs of all the different threads we have, right? So depending upon the stack size that we give in the JVM, it will allocate that many number of threads into the JVM. For example, if you have 128 KB, I'm not sure, it will allocate some 15,000 to 20,000 threads. If you have 256 KB, it will allocate some 11,000 threads. This is all happens for 32-bit. I'm not sure about 64-bit. 64-bit, again, it is again in thousands. The threads limit is always the number of users for a thread. Always it depends on the type of machine that we are using, and the type of stack size that we are allocating in the JVM. Okay, so I have a meeting in another 10 minutes. So we are not done with thread dump yet. We'll talk about thread dump for another 2 sessions, because this is a very, very important concept. You also try to learn everything in parallel, so that I can clarify all your doubts, issues in these ongoing sessions. Okay. Even if you go back, if you wait for an week, and if you think that you can wait for a week and then you can check for the recorded video, I don't think so that will be efficient. You got all your information today, so I would recommend you to install it. Try installing WebLogic 12c generic version using YouTube help. Try to configure JProfiler with this one, and you can monitor all of them. Okay, I'll tell you how to analyze on the different ways to take a thread dump. Okay, and there is always my motto or my focus is mainly about the people who are attending these sessions, is all about you have to clear uh, an complex interview with a very good vendor. Like you should be able to clear a product based company which will give you some 6 rounds or 7 rounds of interview, which will continuously ask about all the different threat dump analysis techniques, or what are the major and minor complex bottlenecks that you have identified as part of your threat dump analysis. If he is convinced with this particular part, you are in. Okay, so that is my main motto, right? Starting from the basics, identifying all the different complex bottlenecks, what solutions you give, and what are all the best practices, what different tools that you have used for random analysis. Okay, that's all for today. Thanks all of you for joining. Thanks for your time. Let's connect tomorrow. All right.
Anzak.
Thank you so much.
Thank you.
Thank you.
Wrote a poem called Pure Joy.